Hello, my name is Evan Amber. I'm a master's student in the Peterman lab at OSU, and today I will present my poster on a study comparing three methods for surveying Eastern Massasauga rattlesnakes. The Massasauga is endangered in Ohio and federally threatened. The two traditional survey methods for Massasauga surveys in Ohio are visual encounter surveys and artificial cover object surveys, which in Ohio primarily uses corrugated tin sheets. These methods are effective, but require intensive field effort with upwards of 25 field visits in a given season for a tin survey. The third method is the adapted hunt drift fence technique, or AHDriFT, which combines passive infrared camera traps with drift fences. We have previously demonstrated that AHDriFT can detect Massasauga, but how it compares to traditional methods remains unresolved. In 2019, we deployed one Y-shaped 3-camera AHDriFT array in each of 13 wet meadow fields in northern Ohio, where we had previously conducted 3 years of traditional surveys. In 2020, we deployed 15 arrays within 2 fields alongside concurrent tin surveys. We compared the detection rates of the 3 methods in terms of catch per person hour, detection probability, and the density of arrays needed to achieve equivalent confidence of absence as a tin survey. We also assessed spatial, weather, and temporal covariates on AHDriFT detection probability. Across the 2 years of our study, AHDriFT obtained 206 Massasauga detections, which is 2 to 4 times the number that we obtained by either visual encounter or tin surveys. In 2019, arrays obtained 0.48 snakes per person hour, exceeding 0.11 snakes per person hour by visual encounter and 0.28 snakes per person hour by tin surveys in the same fields. AHDriFT also outperformed detection rates reported in the literature, with the exception of one study that used an unusual combination of densely placed tin units around a drift fence. In 2020, AHDriFT exceeded tin catch per person hour by 2.6 to 6 times, and was particularly strong in Field A, which is a very dense Massasauga population adjacent to a major overwintering area. We then produced accumulation curves of detection probability per week with increasing density of AHDriFT arrays. We found that only 2 to 4 arrays in a field matched the detection probability per survey of the maximum number of tin deployed in those fields, denoted by the upper horizontal dashed lines. However, arrays placed in less dense Massasauga populations achieve substantially lower rates, so further research is planned to determine the generalizability of our data. Overall, we assert that AHDriFT is a viable method for Massasauga presence-absence surveys in Ohio and can outperform traditional methods. However, AHDriFT is less effective in sites with low Massasauga densities, and further work is needed to discern if AHDriFT can be applied to most fields in Ohio where presence-absence surveys will be being conducted. Finally, for those who are interested in deploying AHDriFT, we found that 70% of our captures occurred from July through September. Therefore, you can follow a recommended survey schedule where you construct arrays in March, but wait to activate the cameras until July, saving time in image processing and field visits. You can then service arrays in August and deconstruct arrays in early October, allowing for a field schedule of only 4 field visits per AHDriFT surveys, which is substantially less than the 25 required by tin in Ohio. Further, we found that AHDriFT detections increased as arrays were placed further away from predator perch trees and placed in denser vegetation, which are both indicative of arrays being optimally placed when they're further away from field edges. And with that, I thank you all for listening to my presentation. Please contact me if you have any questions regarding the methodology or applying AHDriFT to Massasauga surveys in Ohio. Thank you very much.